Hey and welcome. Today we will solve is subsequence interview question. Let's get into it. Here is the first example. We have a source string as ABC and the target string is this one. Now we need to start removing non-matching characters from target to see if we are going to end up with source string or not. In the same order we get it. And if we do, we will return true for it. Second example, if we do the same process again and remove non-matching characters, we will end up covering only A and C characters and not X. So we will return false for it. Let's see how we are going to solve this problem. The idea for this problem is simple. It's just two pointers problem. If we have a pointer for each string and start to iterate through them both at the same time, as soon as we see two matching characters, we would increment both pointers. And if we see a mismatch, like in this case here, we will increment only second pointer because we are looking for source characters within the target string. And this cycle will continue. So at the end, when we are finished with our iteration, if we happen to find all characters of source in the target string, then we might return true for it. Otherwise, false. And you may ask how we are going to detect it. It is simple. If the pointer on the source string has been incremented as same amount of characters count on it, then we are good to return true because then we are sure that we have scanned all characters from source string. Now let's jump into the code to implement this solution. Here we are in Leetcode. First, we need to define our pointer. Then we will do a while loop to check if p1 is less than length of our source and p2 is less than length of our target. And if both of them are true, we will keep doing our job. Okay, what we need to do? First, we need to check about matching point between source and target string. If they match, we will increment only pointer 1. We only increment pointer 1 because the pointer 2 is the one that we are searching within that string. So we might increment it anyway. But remember, if we increment pointer 2 within that if case as well, in this scenario, we will skip some characters checking in target string because in that case, pointer 2 will increment it 2 times when we have a matched character. And finally, we need to see if p1 incremented as the same length of our source string because if so, that means we already found all characters within target string. Now, if I run this, test cases are passing, and if I submit, we are in a good shape here. But let's explore a bit more options now. Okay, that was a super good answer to come up with, but let's take this further. It may seem a bit dumb, but the solution that we are about to go through is the core principle to many other dynamic programming problems too. So let's cook. Since this solution is based on dynamic programming, we might look into break this problem, this whole problem into sub-problems. And for that, we will start from ground up, or better say bottom up dynamic programming solution. So the idea is we will have a two-dimensional matrix of n by n, where the width is the characters from target string and height is the characters from source. And this matrix will hold states of how many matched characters are in between these two strings. But how? First of all, we will have a dumb row and column for both axes of this matrix that will be filled with zeros initially, because in order to calculate the values for actual cells, we need to rely on those empty values. We need a starting point, right? So that will be 0 for us. Okay, for the value of each cell in these coordinates, we will have two scenarios. First is, in that coordinate, if the character from source and target matches. What we need to do in that case is take whatever we have directly from bottom left of that cell plus 1, just because we found a match here. The second scenario is, of course, if the characters are not matching in that coordinate. What we will do, we will take the max of the cell below and the cell to the left to that coordinate. And we will follow this rule until we fill up the matrix cells, and finally, since each cell represents the matched characters count up to that cell's coordinate, then we can easily conclude that the most corner cell will hold the total matched characters count between these two strings. And the interesting part is, if that number is exactly the same as the length of our source string, we know that we have the answer and we might return true for it. As I said, this method is super important in dynamic programming and mostly referred to as tabulation. Now, with that being clarified, let's jump into the code to implement the solution. But before that, I want to mention how encouraging it is to see you like the video and subscribe to the channel. It really supports the work and effort I put into these videos and makes me happy and motivated to make more. Now let's get into it. Here we are in Leetcode again. For dynamic programming solution, initially we need to store the lengths of strings for both source and target because we will use them several times. Then we will create our DP array. Remember that we need to have an extra dumb row and column, and initially they has to be filled with zeros. Okay, now we need to do an iteration over rows and columns and build up our dynamic programming states. Keep in mind that we will start from row and column number 1 because first row and column are just dummy rows and columns. Also keep in mind that we are traversing vertically instead of horizontal. Now within this loop, we need to check two states. Number one is if characters in the coordinates we are matching together. If they match, we will take the bottom left cell's data and add 1 to it. And scenario number 2 is, of course, they are not matching together. If they don't match, we will take the bottom cell and the left cell to that coordinate and choose the max value between them. Finally, if the state in the bottom right corner of our DP matrix is equal to the length of our source string, then we have the answer. Otherwise, false. Now if I run this, test cases are passing, and if I submit, we are in a kind of good shape here. But I want to show you one more thing about why we looked for bottom right corner here. The reason is if I log the DP matrix here and run this one more time, as you can see, this one, and if I just prettify this, yeah, it's gonna look like this. And this is the DP state that we made. Like this row and this column are 0, and we are iterated vertically through these, and we ended up in this corner. And this is like not the same as what I showed in the slides, but I just wanted to show you this because I draw the illustrations in a different way, and how the arrays and matrices has been built in here is kind of different and acts different. But you get the idea. You need to look into the corner in your DP matrix that holds the latest state, which in this case is bottom left corner. I hope that was a bit helpful for you to understand. Now let's talk space and complexity. So the time complexity will be O of n for two-pointer solution, but it will be O of s by t, which s is the length of source and t is the length of target string. And as you see, it is not efficient compared to two-pointer solution, but I just wanted to explain the tabulation in dynamic programming since this is a perfect example for it. And the space complexity will be O of 1 for two pointers, but it will be O of s by t for tabulation because of our matrix states. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put a few more links about different playlists in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.